In this video, we're going to do another balancing example where we're going to review how we actually get the formulas. And in this one, we also need to predict the products as well. But first up, we have hydrochloric acid and barium nitrate. So hydrochloric acid, again, that's one of those binary acids. So you just have hydrogen combining with a halogen. So these are the four that we're referring to. So hydrochloric is referring to HCl. So we have HCl, and since it is hydrochloric acid, that implies it's dissolved in water. So we'll label it as aqueous for the physical state. Next up, barium nitrate. So barium, let's look at our periodic table. Barium is right here, element number 56. And since it's in the second column of the periodic table and it's a metal, it's going to be positively charged with a positive 2 charge because it has 2 valence electrons and it would like to lose both of those valence electrons to achieve a complete outer shell. So it's 2 plus. And then nitrate, so that is a polyatomic ion that you should strive to memorize. And its formula is NO3 with a 1 minus. So to form a neutral compound between barium ions and nitrate ions, we're going to need 2 nitrate ions. So the way we write that, we have the barium, and then since we need 2 of the nitrates, we put it in parentheses with a subscript 2 on the outside to indicate that we have 2 of those nitrates. And then solubility rules. So in another video, I went over them, but just to repeat them again, 1, 2, 3. Group 1 metals. So metals like lithium, sodium, potassium, anything in this first group, if those appear in a compound, it's probably soluble, as in it dissolves in water. And then nitrate compounds and ammonium compounds, if you see those in a compound, it should be soluble. We would label it as aqueous. So barium nitrate should be aqueous just based on that. And then I think I might put my reaction arrow down here because I'm already running out of space because I'm writing so large. But predicting the product. So usually when we've got this kind of format where you've got a compound over here and another compound over here, a double displacement, like that method of thinking is good for predicting the products, which means pretty much have the ions swapping partners. So you can imagine like the hydrogen and the barium switching places, which means we'll have hydrogen ions, and I'm going to write it a little bit differently, and then we're going to erase it. But we'll have hydrogen and nitrates pairing up, and then we'll have bariums and chlorides pairing up. But then when you write those products, you have to think to yourself, what is the formula going to be of the products? Because let me tell you what's incorrect. If you just did H and then NO3, 2, you just copied what you saw here, it's going to be incorrect because this is a 1 plus and the nitrate is a 1 minus, but then you're saying you have 2 of them. You're not making a neutral compound here. So this is incorrect. What we're doing is we're pairing up the hydrogens with the nitrates and then thinking to ourselves, how many of each are going to be required to make a neutral compound? Well, it's going to be HNO3. And then with the barium and the chloride, since barium is 2 plus and chloride is 1 minus, we're going to need 2 chloride to make a neutral compound. So the compound over here is going to be barium chloride, where we've got a subscript 2. So those are the 2 products. And then we want to think to ourselves, okay, are these going to be soluble, insoluble? Are we going to label them as solid or aqueous? Now, HNO3, that is a strong acid, and strong acids are pretty much soluble in water. There's several strong acids that you probably should memorize depending on, where you are in chemistry, where you are in the course, and what level you're at. But there's 6 or 7 strong acids. You can Google them. But HNO3 is a strong acid. We're going to label it aqueous because it dissolves in water. Barium chloride, if we just focus on these solubility rules, it's not following any of those rules because barium is not a group 1 metal, it's group 2. And chloride, well, that's not on here. Now, barium chloride may actually be soluble. We could look it up on Wikipedia and read more about it. But just based on these solubility rules, we might predict that it's solid. And that's okay. Usually these 3 rules are the simplest ones that we ask students to memorize. Anyway, for balancing, and I think I'm going to rewrite it just a little bit. to make visualizing the balancing process a little bit easier because I got a little messy here. But those are our reactants in our products, and we got aqueous, 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 and I'll keep this one as a solid. So I'm going to go ahead and use this column approach. So we have hydrogens, chlorine, barium, and I think I'll go ahead and keep the nitrate as a single unit, like I've done in another video. So now counting up what we have on each side. So I see on the left side, we have 1 hydrogen, 1 chlorine, 1 barium, and 1 nitrate. And on the right side, I see we have 1 hydrogen, 1 nitrate, 1 barium, and 2 chloride. Okay, so it's clearly not balanced already. This is the biggest problem right there. So let's think about what do we need to do. So chloride, if we need another chlorine on the left side, we would have to put a 2 right here. So now we need to update our count. So if we put a 2 in front of HCl, that means now we have 2 hydrogens and 2 chlorines. Okay, now the hydrogens are out of balance, so we have to fix that. And this is kind of how balancing is. You have to just go back and forth and, trial and error, just keep working at it. So let's see, if I put a 2 here, then that'll make the hydrogens balanced. So updating my counts, I'll have 2 hydrogens there, but now I have 2 nitrates on the right side. Oh, and you know what? I made a mistake originally. This was 2 to begin with. There's a 2 right there. I made a mistake. And that means it's actually balanced now. So hydrogens are balanced, chlorines are balanced, bariums are balanced, nitrates are balanced. So if you saw that mistake right when I made it, nice job. Shame on me for making such a mistake on a YouTube video. Anyway, it's balanced now, and I hope you found this video helpful.